In this video, I'm going to go through lesson 1.6 on solving absolute value equations. Before we start, I want to think a little bit about what is absolute value. What does it mean? What does that notation look like? And absolute value measures the distance a number is from zero. And it's also important to note that it is always a positive number. So, for example, if I was thinking about a number line, here's 0. If we think about, for example, the number 5, and we think about how far this is from 0, we would say that it's 5 units away from 0. But if we think about the number -5, that is also 5 units from 0, and that would be a positive value. We say distance is always a positive value. We can't have a negative distance. So similarly, if I think about the absolute value of 5, and this is how we note that with these vertical bars on either side of the number, that means the absolute value of whatever's inside. So the absolute value of 5 is just 5. The absolute value of -5 is also 5, okay, just like we showed on this diagram here on the right. So this always has to be a positive number. If we start thinking about the absolute value of some variable, that's when things might get a little bit different. Because if I think about the absolute value of x, so say I say the absolute value of some number x is 5, well then what are the possible values of x? And we have two different options here, and we kind of looked at these already. So one option is 5, right? The absolute value of 5 is positive 5. So it is possible that x is 5. But we also saw that -5, the absolute value of -5 is also 5. So x could also be -5, right? So we say that this might have more than one solution. Right? There's more than one value of x that would make this equation true. And we're going to see that that often happens with absolute value. Final quick one I want to show you is this. What if I were to say, well, the absolute value of x is -5? And we might think to ourselves for just a second here, so remember this tells us to basically, it's always going to be a positive number. One way to think about this is, if that number is negative, then just make it positive. But is there any number out there that I can make positive and it will equal -5? The answer is no. There's nothing I can put in here because absolute value makes those values inside positive. So this actually has no solutions. And we'll see a couple different cases like this, but whenever we have the absolute value of something equals a negative number, we know that that can't be possible. There's no possible value of x that could make this true. So let's look at a couple examples. Knowing that I've got this variable inside here, so something -4, I take the absolute value of that and it equals 6. Okay, so there's more than one number, there's more than one value of x that could make this true. And to find those values, we actually need to split this up into two different equations. Right? So whenever we have this the variable in here, we're going to split this into two separate equations. And here's how those equations look. I'm going to take the absolute value away. And one equation looks exactly like it did originally, where we just take away the absolute value. Or we have that same value that's inside the absolute value signs, and then I have to change the sign on the other side of the equation. So either of these things could be true. And we'll solve both of these equations and we'll get two different answers. When we solve these, we solve them just like we always have, right? I'm trying to get x by itself. I'm trying to find that value of x that makes this true. And so all I would do is add 4 to both sides. And we would get x equals 10. When we do it on the other side, same process, plus 4, we would see x equals -2, because -6 plus 4 is -2. We could check our work, right, by just plugging this value back in for x, and we could see that both of these are appropriate solutions. So we can probably just kind of do this quickly. If x is 10, 10 minus 4 is 6, and the absolute value of 6 is 6. So this does make our equation true. How about this one? If x is -2, -2 minus 4 is -6, and then the absolute value of -6 is +6. So both of these values make this equation true. This says to graph the solution if possible. We talked about absolute value being a distance. And this part will make a lot more sense once we get into graphing more of our equations. We can think of this as a number line with a distance, but this number attached to the x is going to kind of shift that, so the center isn't going to be 0. The center would actually be 4. And you'll find that both of our solutions are 6 values away from 4. So if we take 4 plus 6, we end up at 10. And if we take 4 minus 6, we end up at -2. Those are our two solutions, and this is how it relates back to our equation. Okay, if this were just x, then it would be, distance from 0. Our solutions would be 6 and -6. But since I've subtracted 4 here, that shifts my center. And my two solutions become 6 away from that center. Moving on to part B. Let's take a look at what we got. We've got absolute value of 3x plus 1 equals -5. And this is what I want you to notice, is that whenever we have this negative on the right, is this possible? Is the absolute value of anything in here ever going to be a negative number? And the answer is no. This is no solutions. So that's only in this case when we have the absolute value of something equals a negative number. There's no way that that's possible. We end up with no solutions. And we'll see an example that's similar in just a second, but also a little bit different. Okay. So that example is actually right here. Notice how this is different from what we've done before. I've got my absolute value, but then I've got minus this other value equals a negative number. So now we can't immediately say no solutions because it's not just the absolute value equals a negative number. We've got this other minus 10 that we have to take care of first. And we always want to do that, right? We need to get the absolute value alone, then we can split it into two equations. Okay, so that's how this changes moving into example 2. So to get rid of that minus 10, we're going to add 10 to both sides. That leaves us with the absolute value of 3x plus 9 equals 6, because -4 plus 10 is going to be 6. And now we see we're okay. There are solutions because I have an absolute value of something equals a positive number. So now we're going to split it into 2. 3x plus 9 equals 6, or 3x plus 9 equals -6. Solve both of our equations. Subtract 9. 3x equals -3. Divide both sides by 3. To get x by itself, you get x equals -1. And it's going to be the same process over here, -9 from both sides. 3x equals -15. It's -6 minus 9 is -15. Divide both sides by 3, and x equals -5. So once again, we have two different solutions. If we were to plug those values back into our original equation for x, we would find that both of those make this equation true. Okay. Moving on. We may end up with absolute values on both sides, right? Absolute value equals absolute value. We basically handle this exactly like we did the other stuff. I'm going to split my equations and then multiply by -1. So I'm going to split this up. So I've got 3x plus 4 equals x. So I'm just taking away both absolute values. Or 3x plus 4 equals -x. And then I'm going to solve both of these equations. On the left side here, I'm going to subtract 4 from both sides. Remember, when we've got variables on both sides, our goal is to get all the variables to one side, all the numbers to the other. This could be one way that I would do that. 3x equals x minus 4. We could have also just subtracted 3x from both sides. Honestly, that might have been the easier way to go. That would save us a step in our solving process. Because now I've got to subtract x from both sides here, and I end up with 2x equals -4. Divide both sides by 2, and I get x equals -2. For my second solution, follow this same process. Actually, let's do this one the other way, because it doesn't really matter, and I think that'll save us a step. -3x minus 3x. We get 4 equals -4x. I'm going to divide by -4, because that's what's attached to my x, and I get x equals -1. Next, this is where this rule makes a little bit more sense. When it's just a single x here, we can say, okay, well, it's got to equal x or -x. When I've got this whole expression on the right side, notice how we handle this. I'm going to split and multiply both sides by -1. So I've got x plus 5 equals x plus 7, or x plus 5 equals negative x plus 7. So this negative out front really acts as a multiplying by -1, because I have to distribute that negative to both of my values here. So we'll see that in just a second when we solve. So in my left-hand equation, let's just do this. If I subtract x from both sides, we end up with 5 equals 7. And we can just stop right here. We've seen this situation before where both of our variables cancel out, and we're left with a statement that is untrue that tells me that this has no solutions. Okay, but that's just this equation. I could still have a solution for the other one over here. So first I'm going to distribute that negative, so this would end up as -x minus 7. Add x to both sides. We end up with 2x plus 5 equals -7. Subtract 5 from both sides, and we end up with 2x equals -12. And when we divide by 2, you should get x equals -6. So in this case, we just end up with one solution because the first equation did not have a solution. So these are the three that you should definitely try on your own. Look back up above at the examples and use those as a guide. I'm going to go through these really quickly, but give them a try first and see how you do. Nothing unusual in this first one. We're just going to split this into our two equations. 3 plus x equals 1/2, or 3 plus x equals negative 1/2. To get x by itself, we subtract 3 from both sides. This is going to be true in both equations. So on the left equation, we end up with x equals negative 2.5, because 1/2 minus 3 is negative 2.5, or x equals negative 3.5. And we could plug those back in to just double check our work. Next, we've got our absolute value plus 5, so I got to get rid of that first. Then I can break it up into two equations, minus 5. So x minus 2, absolute value equals 4. Now we can split it up, because I've got my absolute value equals some number. So x minus 2 equals 4, or x minus 2 equals negative 4. And I'm going to be a little bit crunched for space on this last one. On the left here, add 2 to both sides, do the same here. We end up with x equals 6, or x equals negative 2. And both of those answers should be good. Finally, we're going to see something a little bit different here. When we have a variable on the right side, notice it's not an absolute value, it's just a 4x. When I get my solutions, what I need to do is I need to make sure that this doesn't end up being a negative number. Because I have an absolute value of something equals, if this ends up being negative on the right, based on my x value, that solution is invalid. It won't work. Let's set this up. 2x plus 12 equals 4x. And I'm actually going to go below just to save space because I'm running out. 2x plus 12 equals negative 4x. So when I solve up top, I'm going to start by subtracting 2x from both sides. That'll get all my numbers on one side, all my variables on the other. 12 equals 2x. Divide both sides by 2, you should get x equals 6. And that solution is going to be okay, right? Because 6 times 4 is 24. That's a positive number. Next one, I'm going to start the same way. Subtract 2x from both sides. Now I've got 12 equals negative 6x. And since that's a negative 6, I have to divide by negative 6. And we end up with x equals negative 2. However, notice when I plug negative 2 in here for x, I would end up with a negative 8 on this right side. And this can't be true, right? If this is the absolute value of something, it has to be a positive number. 4 times negative 2 would be negative 8. So this solution down here does not work. Okay, this would only have one solution. And it would be this negative 6. I'm sorry. It would be x equals positive 6.